Hello and welcome. PilotSafety.org is a volunteer group dedicated to reducing general aviation accidents by providing free and low-cost training and safety resources for pilots. Learn more now at pilotsafety.org. Our speaker today is Gary Reeves. Gary has over 6,000 hours, is an ATP, and a master flight, instrument, and multi-engine instructor. He volunteers as a Young Eagles flight leader for the EAA and a nationally recognized expert in Garmin avionics, IFR, iPad use, and mountain flying. In 2016, Gary was awarded the FAA Instructor of the Year for the Western Pacific region, which includes Arizona, California, Hawaii, and Nevada. This means he is one of the top 8 instructors in the whole country. There are 112,000 instructors in the U.S. Less than 800 have ever been named Master. California only has 13. Please welcome 2016 Western Pacific Regional Instructor of the Year Master CFI, Gary Reeves.
Hi there, everybody. I just get a kick out of picturing somebody watching a DVD or an online video at home and clapping. That would just kind of make my day. So, of course, I volunteer for pilot safety. What I actually do for a living is I own a company called masterflighttraining.com. And what I do for a job is I actually travel all over the US and Canada and teach people how to use G1000, Garmin 430s, GTN avionics. That's what I do. Is I actually come to you, I train you in your airplane at your airport, and that's kind of what I do for a living. I also do some IFR training, iPad, and mountain flying. So let's talk about the basics. We're going to talk about a bunch of abbreviation and nav terms. We're going to get pretty technical and learn what's behind the screens. We're going to talk about the function of every single key and knob. We're going to go really in depth to the PFD display, and I'm even going to show you a power on self-test. So before we start, I want you to sit back, relax. You may want to hit pause, get yourself a Red Bull or a coffee. This is the most technical and in-depth portion of the training series, but it's very important that you understand the system, not just when to push a button, because understanding the system will help you out when things go wrong. So let's talk about some important abbreviations. First of all, ADSB is Automatic Dependent Surveillance Broadcast, and it's, as of this date, March 5th, 2016, not really available for the G1000. They haven't figured a workaround yet. They will. I'm sure it'll be out within a month. They just haven't figured it out yet. AHRS is the Attitude Heading Reference System, and that's really what the biggest benefit for people is in going to a glass panel, is you get a much easier read display all in one look where you don't have to look at 6 different instruments. ALT is, of course, altitude, and amps in this case means amperes, which is the charge going in or out of the battery. So if you see a negative or a plus, you'll know whether your battery is charging or discharging. So at this point, if you look at the picture, the main battery is charging at 0.5 amp per hour, and the standby battery is just 0, which means it's not being used. AP is the autopilot, APR is the approach mode. Baro means your barometer, your altimeter. And then BAT means the battery, as we previously showed. BC is a pretty important button for most autopilots. You need to activate that whenever you're flying a back course. BRG is the bearing 2, and that actually comes up in little side windows behind the HSI if you select them, and it literally just points to the bearing, and it also gives you a GPS distance. CDI is the course deviation indicator. And when you see something that says checklist, You can actually open up checklists. Now, as a personal preference, I typically do not use the checklist inside a Garmin system. I prefer a paper checklist because sometimes when you pull up a checklist, it interferes with the screen that you want to do things on. So it's not my typical favorite to do it. I prefer paper checklist or an electronic checklist on an iPad or an iPhone. CHT is cylinder head temperature, and you're going to use that or the exhaust gas temperature to lean your system. Typically, in most planes, you're going to use the exhaust gas temperature, but you do need to understand your EGT and CHT limits. They may very well be in the pilot's POH, I'm sure they are, but you probably want to invest in actually buying an engine operating manual, which most people don't typically buy and read. And an engine maintenance manual is also very good reading. CLR is the clear button. It does a couple different things, and I'll show you that. COM is communications. And when you see a button that says CRS, that actually steers your course. So you can pick a course to or from a VOR or an NDB if you happen to have an ADF installed in your plane. When you see CRSR, that means you push the center of the button to activate the cursor. The big knob moves the cursor. The little knob in the center always changes it. To get rid of the cursor, you just push that center button again. CTR is center. CUM, when you see CUM, that's the cumulative safe distance. Obviously, CYL, they mean cylinder. Now, the Declutter box is actually important because it changes what's displayed on maps and inset maps. So I typically don't need airspace lines because I'm flying IFR. I declutter and remove them. So you actually remove stuff you don't want to see to make the whole thing easier. And I'll show you how that function works. DEC is decrease. DIS means distance. And DME, distance measuring equipment. A lot of people think DME is going away. That's not necessarily true. I flew a G1000 equipped airplane that was required by law to have DME. That's because it flew over 18,000 feet. So when you fly in the flight levels, you are required to have DME. And it's an additional box that pops up on the PFD if it's selected. DN is the down, and that's actually in part of the Garmin flight control system, the GFC 700 autopilot, where nose down increases your vertical descent rate. So if you push the nose down button once, you'll go negative 100 feet per minute. So it's not a vertical speed button, it replaces the vertical speed button. DP is the departure procedure. DSPL means the display. And DTK, a lot of people get wrong. They say, oh, that's the direct track. No, that's the desired track that you've programmed in or is built into an instrument procedure. When you see the D arrow button, that means direct to. You'll notice I've highlighted the exhaust gas temperature, and that's typically how you lean a plane with the G1000. It depends on your POH, it depends on your mechanic and your engine operating manual. I typically like to run my engines 50 to 75 degrees rich of peak, and we'll show you how to lean that system. EIS is the engine indicating system, and anytime you see emerge or emergency, that's obviously emergency information. ENG means the engine. ENR is your Enroute. ENT actually means your enter button. And, you know, it's funny, a lot of people go, Gary, you know, don't know why you're going over all these buttons. Because I've trained Garmin avionics for over 10 years, and I will tell you a lot of people don't understand the abbreviations and actually make mistakes. So it may be a little repetitive if you have a lot of experience, but trust me, I promise you'll learn something you didn't know. ESA is your en route safe altitude. ETA is your estimated time of arrival, and you can program that to be in local time or Zulu time. ETE is your estimated time en route, and people mix these up quite a bit. FD is one of the best parts about the G1000, but most people don't use it effectively, and that's called the flight director. So basically what it does is it puts little purple bars and you take your command bars and line up with them. So your job is to make the yellow perfectly fit inside the center of the purple. And it actually takes all the work out of flying instrument approaches and flying IFR. Just a lot of people don't have a lot of experience with it. I will tell you, once you get trained on a flight director, flying instruments without it seems antique. FF flow is fuel flow. The FLC is flight level change. And I will tell you, for most piston G1000 equipped aircraft, I typically do not use the flight level change. I prefer to use the vertical speed mode, which is nose down and nose up. The flight level change tries to maintain a constant airspeed, but it does that by trimming on most piston aircraft because it does not have an auto throttle. So I prefer just to use the vertical speed mode with nose up and nose down. FMS is actually everything involved in flight planning, and that's the flight management system. Of course, FPL means flight plan. Now, the flight plan button opens up two completely different windows depending whether you push it on the PFD or the MFD. GAL, of course, means gallons. GND is ground, and it's a transponder mode. GPH, of course, gallons per hour. And this is a good way of rough leaning until you can get to the point where you can fine-tune it. GPS, of course, is the global positioning system. That's, the big thing behind the G1000. And when you see something GS, that's actually ground speed, which will be different than your indicated or true airspeed. HDG is your heading button. And not only is it in the Garmin flight control system, it's also on the King autopilots, and you actually have a knob to set a heading bug. High, of course, is high. HRS is hours. And HSI is the horizontal situation indicator. And this is what we have on a G1000 is when you overlay a course on top of a directional gyro so you can look at one window. That's what an HSI is. IAP, of course, is instrument approach procedure. The ID button is not identify on a transponder. The ID button is allowing you to listen to the Morse code on the G1000. Now, if you have a nav frequency tuned in on the G1000 and it shows you the letter identifications, for instance, SLI next to 115.7, that would be Seal Beach VOR, then it has listened to the Morse code and identified it for you. So if you see an identifier next to the nav frequency that's active, you don't have to listen to it. I recommend people do, just to get in the habit and stay in good habits. I also like to listen to VORs and localizers, the Morse code on a low volume, all the way through an instrument procedure, so if it stops, I know it. Now, ident is what you're looking for on the transponder feature, and that would be shown just like that. IN is, of course, inches. INC is increase. INTEG is integrity, and that's if the GPS signal is usable for your primary form of navigation. You'll get an integrity warning when it's not. Speaking of knots, there it is, KT. And LO means low. LOC is your localizer. The LRG, when you see it, means large. And the LRU is actually what makes up the G1000. And we're going to spend a lot of time talking about line replaceable units. But the magic is you have several of these behind the screens, and when one breaks, they literally pull it and replace it. They don't work on it, they pull it and replace it, and then fix the old one. So an LRU makes the G1000 a really wonderful avionics suite, and Garmin absolutely, in my opinion, makes the best in the world. Avidyne is wonderful, and other companies are great, but Garmin is the best avionics to me through my experience. And one of the things that makes the G1000 so wonderful is the fact that when one thing breaks, it's an easy 30-minute swap. It makes it much, much more affordable. If it was all built into one system, when one thing breaks, your airplane would be down for weeks. And the easiest way I can explain LRUs to people is I tell people never ever buy a TV with a DVD player built in. Because if the TV breaks, you're out everything. If the DVD player breaks, you're out everything. It's easier to have a TV and an independent DVD player and then an independent streaming network service like a Roku. The more things you stuff into one box, the more you lose if one of them goes wrong. So having independent line replaceable units is actually a really good thing. When you see LTNG, that means there's been a lightning strike if you have the storm scope installed. MAN is the manifold pressure. Of course, MAX is maximum, and that's usually torque and airspeed is when you'll see stuff like that. Prop RPM. MED is medium, and MFD is the right screen, or what we call the co-pilot screen. So the multifunction display has more things on it, and you can do more on it. Min is, of course, minimum. Nav is important. It's part of autopilots, both in the King and the Garmin flight control systems. And what it's telling you is you're actually going to track the navigation system. Now, one of the most commonly missed things on instrument check rides is people tracking the wrong course. It's very common for people who don't understand Garmin avionics to track a VOR course while still on GPS, which of course is an automatic failure. NexRad is the next generation radar, which is available with XM weather subscriptions. NRST is a button you really need to know where it is at all times, because that's the button you're going to use in all emergencies first. OAT is the outside air temperature. OBS is an omnidirectional bearing selector, and I'll show you that. When you see OPTN, that means there's more than one option. Typically in the wind, there'll be 3 different options in the wind window. PFD is your primary flight display, and that's what you see in front of the pilot side. That's the attitude heading reference system. That's where your HSI is. That's where you're looking most of the time. PRES is pressure, typically a low or a high fuel pressure. PROC is the instrument procedures that you can pull up. QTY is quantity. That might be a fuel quantity. That might be a TKS anti-icing fluid quantity. And of course, if you see an R on the transponder, you're getting a reply light. Now, I always like to talk about the reply light. It is entertaining to no end to listen and have people argue with air traffic control when air traffic control says, well, radar contact lost, or we don't see you. And pilots come on and go, well, I'm getting a reply light. Okay, when you get a reply light on an older transponder, or you see an R in reply indication on the G1000, it doesn't mean they see you, it means somebody sees you. That means radar beam hit your transponder. It hit your plane. But it could be from the Southwest Airlines behind you. It could be a military radar. It could be any radar. It doesn't necessarily mean that the controller you're talking to sees you. So if you are flying along and they say radar contact lost and you're still getting a reply light, don't argue. It doesn't mean that they're seeing you. It means somebody is seeing you, but you never know who. Now, RAIM, Receiver Autonomous Integrity Monitoring, is an ability of the GPS to self-check and provide accurate navigation. So you should actually do a RAIM check at your destination before every flight, and we'll show you how to do that, especially if you're going IFR. REF is a reference number. RNG is range, and you can see the range button where you can turn it left and right. RPM, of course, is revolutions per minute. That's your prop speed. RST is your reset button. RSV could be pretty critical. You can actually program in what your fuel reserves are. What I always do on the G1000 is I change my fuel reserve ring to 1 hour instead of 30 minutes. So I prefer to show a 1 hour reserve at all times. And what's great about the G1000 is when you see the fuel reserve rings on the multifunction display, you'll notice if you have any kind of wind that they're not round, they're actually egg-shaped. So it gives you a hint which way you can go in trouble and get even farther. RX is the receiving comm. So if you see an RX in your nav or your comm 1, but you don't hear anything, welcome to America. Welcome to the most probable cause of radio failures in the US, pretty much everywhere in the world, I'm sure. The most common cause of radio failure is actually having the volume turned down or the wrong button pushed. So if you're talking, you should see a TX, and when you hear something, you should hear an RX or see an RX. If you see an RX but you don't hear anything, either your volume's turned down, your headset's unplugged, or you got the audio panel set wrong. And look, there's standby in the transponder. Now, towered airports actually have made a change. Most busy airports, especially Charlie and up, actually want you to leave your transponder in altitude modes at all times, even while you're moving on the ground, because ground radar is using that. Unfortunately, the G1000 has a little bit of an issue. There is no way to alter the fact that the G1000 always goes to standby or ground mode after you land. So you have to manually change it to altitude. SLCT is your select. SPKR is your button that allows you to do speaker. And that's actually kind of a handy thing. I like the speaker on in the background, and it's a good way to check if you're having headset problems. SQ is your squelch button, and I'll show you all about that. If you see STD, that means standard, so it could be your standard baro setting, or it could be something else. Storm scope is actually an optional unit. You can install a storm scope, which is a great way of seeing lightning. And it is not necessarily real time, but it is much, much closer than XM weather. It's pretty good. It's almost instantaneous. SUSP is an important button if you are an instrument pilot, and it's about suspending auto sequencing through the flight plan. Typically, that's really important if you are in a procedure turn that turns into a hold, or you need to push this when you go missed approach. Sync is a way of synchronizing things. TA is a traffic advisory, and I'll show you what that alert looks like. TAA is, by definition, any airplane equipped with a G1000, a GPS, or an iPad. You are now a technically advanced aircraft. Anything that's got a moving map and weather and flight planning capabilities and all that stuff requires training. I think the biggest mistake possible with Garmin system is people who buy an airplane with Garmin or install Garmin upgrades and never take professional one-on-one instructions with it. Now, I will tell you, these DVDs are going to make you really good, but please, to be safe, to go way above minimums and to protect you and your family, hire a master instructor in your area, somebody with a lot of Garmin experience, and just do a little bit of one-on-one training. It's important that when you're in the air, you have somebody who knows how to work the buttons. TAC, of course, is your tachometer. And TAS is typically your true airspeed when you see it, but it's also an abbreviation for a traffic advisory system. TAWS is your terrain awareness system. Shows you stuff you're about to hit and stuff when to avoid, stuff when to climb. Temp is your temperature, obviously. Now, term is actually a terminal mode GPS sensitivity. As you fly along, your GPS, the CDI, how off you can be, what each dot means, changes. It goes from 1 mile to 2 miles, and then during the final instrument approach, it comes all the way down to 0.3. So your CDI becomes more sensitive as you fly, and terminal mode is when you're within 25 miles of the airport. TIS is a traffic information system, and there's two different, there's actually 3 different traffic systems that could be installed in your airplane. One is TIS, one is TAS, and one is TCAS. TIS and TAS actually steal the radar signal from an air traffic controller, a TRACON. TCAS is actually actively interrogating other airplanes. TMR is your timer button. TOD is actually important in your vertical navigation. You'll see it on your MFD, and it means the top of descent. That's when you're starting your descent. Topo is the topographic map, and that's basically showing elevation contours. It shows you hills and such. TRK is your track. Remember that TX, you're going to look by your frequency. If you push the button and talk and nobody responds, push the button and talk again, make sure you see a TX. Then again, if you see an RX but you don't hear them, you got a volume issue. VAC is your vacuum system. And a lot of people don't pay a ton of attention to this. G1000 airplanes are equipped with a vacuum pump because you have standby instruments that rely on them. So, true story, I was training somebody out in Arizona with a Garmin airplane. Didn't know a ton about Garmin before I got there, but bought this very nice G1000 182, and his vacuum was just low. And he kept getting alerts that said low vacuum. I'm like, why are we flying the plane? He goes, well, it's not needed. It's not part of the G1000. I'm like, well, it kind of is needed. It's a required part of airworthiness because it runs your standby instruments. So really important to keep an eye on that as well. VG, of course, is your best glide speed. VNV, vertical navigation, is one of the coolest parts of the G1000. You can actually, if you have the Garmin flight control system, put in your altitudes on an entire 3-hour cross country, including departure procedures, stars, and instrument approach procedures. And if you do it right, it will actually change altitudes automatically for you. And the only thing you need to do is then help it along with adding or reducing throttle. VOL is your volume button, which is the same as the squelch button, and I'll show you that. VR is your best rotate speed. You can change your flags for VG, VR, VX, and VY. You can actually change them if you don't like the ones that come auto-programmed. VS is vertical speed, and VSI, of course, is your vertical speed indicator. VX, best angle of climb. VY, best rate of climb. And WAS. Now, wide area augmentation system, or LOS, local area augmentation system, is what generates the glide path for instrument approaches. It is a ground-based station that provides better correction and more accuracy and generates a pink dot instead of a green dot, which is a glide path, never a glide slope. Unfortunately, just the fact that you have RAIM and you've checked RAIM does not mean the WAS is working when you get there. So RAIM means lateral navigation. WAS and LOS is vertical navigation. And it's typically at areas with busy airports that usually have an ILS instead. It's much cheaper to run than an ILS. And by the way, your autopilots love WAS-based approaches, which we'll discuss later. you're actually going to get something called an LPV approach. WPT is a waypoint, and it's actually a whole series of different pages, which we'll cover in detail. Now, XM is satellite radio, and yes, by the way, you can absolutely listen to music as you fly. It's an additional monthly subscription. Now, the nice thing about it is you can set this, and the default setting is that anytime you talk or anytime a radio transmission comes in, it instantly mutes the music coming in. So that's very nice and makes it safe. But the other part of XM that most people don't associate is, yes, there's two XM subscriptions. One is audio entertainment. You can listen to country music as you fly over the country. But there's also an XM weather subscription, which is very similar to the ADSB weather that people get on their iPad. Pardon me. The difference is first of all, XM and both ADSB weather are never ever real time. It's never right now. There's YouTube videos where people are navigating between thunderstorms using XM and ADSB weather. They are the dumbest human beings on the planet. Thunderstorm activity can be up to 28 minutes old, both on XM and ADSB. However, the difference is ADSB typically only shows you weather within a couple hundred miles of your airplane. XM, if I'm in California, will show me the current METAR at JFK, New York. So it kind of depends on what's built into your airplane and how fast you're flying to whether you want this or not. XBDR is your transponder key, and XTK is your expected track. Okay, so let's talk about what's actually behind those 2 or 3 pretty computer screens. Well, if you take those things out, and I really recommend letting the avionics technician do this, you're actually going to get a bunch. And depending on how many options you've paid for, what kind of equipment you're flying, you're going to get a bunch of independent computer units that are called LRUs, or line replaceable units. So they're a bunch of independent computer components that talk to each other, much like your VCR talks to your TV. I'm sorry, did I really say VCR? I meant, of course, Blu-ray DVD player. I really should take the 8-track player out of my car one of these days and come into the 20th century. But it really is computer programs, and they actually talk by Ethernet cables most of the time. So this is a pretty basic system of an LRU, but what's important is that the two displays are both Garmin display units. They're identical computer display monitors. They're identical, but they're just programmed to show different displays or different information. But what I want you to realize is that they actually talk to each other the whole time. So that if you lose one monitor, you can go into something called reversionary mode and put everything on one screen, and it doesn't matter. Same thing with the avionics systems. They're actually talking to each other. So even though one component might just go into one unit, it doesn't matter because all these systems are interconnected by, no kidding, Ethernet and LAN cables. So the easiest way to explain all of those things are to make it familiar with a steam gauge airplane. Your Garmin display unit or primary flight display, think of it as your 6-pack of instruments. Your air data computer, picture it like your pedostatic system. The MFD is your moving map. The GIA, the Integrated Avionics Unit number 1, think of it as your number 1 radio with a GPS. That's why on a G1000 equipped airplane, you'll actually see 2 GPS antennas. AHRS, your attitude, rate of turn, Slip skid, think of it as your gyroscopes. The GIA2, of course, is radio 2 with a second GPS. Why do we have two different radios? In case one breaks. Why do we have two different GPS antennas? In case one breaks. And the magnetometer, pretty simple. Think of it as your compass. It's actually solid state and it doesn't move. It's even more accurate, but think of it as a compass. Now, when you buy the airplane, and even after you buy the airplane, you can buy some options. You can put even more line replaceable units back there. And a lot of people have noticed that the newer Cessnas, the newer Pipers with the G1000, actually can carry less weight than the old steam gauge. That's right. All of this is some solid state heavy computer stuff. And you just keep packing 2, 5, 10-pound units behind the dashboard. That weight adds up. So let's talk about some cool optional units. If you would really like, you can even add an ELT. The most common question I get is, well, it's required. Well, it's required some places. So the ELT is actually considered an optional unit. Don't worry, yours will come with it, I'm sure. You can buy a storm scope, which shows lightning and thunderstorms. It helps you avoid the worst of the cells. You can put in an ADF. Yeah, no kidding. Especially in Alaska, they still do a lot of ADF navigation. Why would you need an ADF? Because GPS does break. GPS does go out. I am nowhere near Beatty, Nevada. I'm in Southern California by Disneyland. And every so often, my GPS signal will cut out and become inoperative because they're doing GPS testing way the heck over the hills in Beatty, Nevada. GPS is not foolproof and you can lose signal. So especially in Alaska, you'll actually find they put in those ADF receivers. Again, if you're going into the flight levels, you're going to have to have DME. I highly recommend everybody puts in a carbon monoxide detector. The little paper stick-on ones that you see in the cockpit are totally useless. They only work for about 30 days at best, and lethal levels aren't even easily shown or happen quick enough. You want an audible alert and a siren, so I recommend everybody use an electronic carbon monoxide detector, and the G1000 you can actually build one in the system. And of course, there's your traffic avoidance system. You'll notice that there's not an LRU for ADSB yet, and again, it will. Now might be a good time to put this program on pause, stand up and stretch, because I'm going to cover 57 different buttons and knobs in details. And again, it's really important that you understand when and how to use all these buttons. So let's start out, and again, some of it may be repetitive for you, but I guarantee if you hang in there, we're going to learn a couple things, even if you're fairly experienced. First of all, the easiest way to use the primary flight display and the multifunction display is never touch the far sides. And what I mean by that is simply only use the center controls. So when you're flying, all radio navigation, autopilot, audio panel, everything is done with the right hand. If you're the pilot, or the left hand if you're the co-pilot. Why do I want you to use your right hand if you're the pilot anyway? Because you're used to it. You're used to having the audio panel right in the middle. You're used to having Comm 1 and Comm 2 vertically stacked on the left. And you can even see the squelch volume knob, the flip-flop, and the big and little tuning knobs. Remember, little knob tunes little numbers, big knob turns big numbers. And it's pretty familiar to have your navigation radios 1 and 2 vertically stacked on the right. So it makes the transitioning to this very easy. I'm always a little bit concerned when pilots take their left hand off the yoke, let go, and tune a nav radio. I really prefer you just use the center buttons only. Look, the volume, the flip-flop, and the tuning knobs are all the same. So get in the habit of only using the center part of your G1000 system. Let's talk about the first 4 buttons to the primary flight display or the multifunction display. That is the volume and ID button for your nav aids, your nav flip-flop button, which is technically called a frequency transfer, but it's a flip-flop. Your dual tuning knobs, remember little knob, little numbers, big knob, big numbers. And you have a heading knob to set a heading bug. And let's show that. So, using my right hand, see when I push the buttons an ID comes up next to the nav aid frequency? And then if I push the speaker, I can listen for the Morse code. Now you'll notice that I full has already identified it. Now I can tune up the volume or turn down the volume. And you'll notice I also have to select nav 1 to hear it. Now if I'd like to change the frequency, the top is under a blue bar that's called a tuning box. I'll use the little knob 115.7, transfer it over. If I want to tune the bottom frequency, I need to move the tuning box by pushing the center. Big knob, big numbers, little knob, little numbers, and then flip-flop. Notice what I say about reversionary mode. See how everything's now on both screens? And you can see me moving the heading bug by twisting that heading button. If you push it, it will automatically go to your current heading. Let's talk about the comm buttons and knobs. You have a joystick, which is range and moving, panning on maps. You have your course and barrow knobs. The barrow knob, and people mess this up all the time, it's just totally fine, everybody does it. You get a new altimeter setting and you grab the triangle inner button and change your course. Altimeter is a bigger gauge, think about it as a bigger gauge, is the bigger knob. Changing your course on VOR or localizer navigation is done with the little triangle button, and think of the triangle inner button as the head of an arrow. Of course, you have your dual comm tuning knobs. Little knob, little numbers, big knob, big numbers. You have your comm volume and squelch. Your comm frequency transfer. Let's see how all that works. So, here's my range button. And what you do is the range button changes the inset map. If I want to change the PFD, this is the time I actually have to use the joystick and the range knob on the right side. This is the one time you want to, depends on which one you're going to move. Barrow. First of all, let's change my course. So I'm going to move the arrow knob. See how I'm setting in a course 2 of VOR. The big knob is barrow. You can see my altimeter changing. Big number, big knob, little number, little knobs in the comm window. Flip flop. And you see that RX. That means somebody is talking. In this case, it's going to stay on because it's tuned to an ADS. And same thing, you move the tuning box up and down by pushing the center of that button. That's how you change the volume. Okay. Let's go into the flight management system. And this is basically your flight plan and your GPS navigation system. So the 10 button is that direct to button that I told you about. 11 opens up a flight plan. And again, sometimes you want it on the primary and sometimes you want it on the MFD. The MFD will allow you to do vertical navigation. The primary flight display will not. The clear button, you can actually remove things from flight plans. You can go back to a default map. It actually does a bunch of different things. The 13 is the dual MSS button. You have to activate the cursor by pushing the center of the green part, the inner dot. Then big knobs move the cursor, little knobs changes items. So it's data entry and selection. Of course, we have a menu button that will bring up options. We have a procedure button for not only instrument approaches, but departure procedures and stars. We have an enter key, so let's play with those knobs. Direct to, my cursor's active, so I'll use my little knob to change it to L, big knob to the right, G, big knob to the right, B, then push enter. I'm now, if I push it twice, direct to Long Beach. And you can actually see it in my flight plan. If I push the menu button, those are my options for that particular window. So let's put in a little bit of a flight plan here. You do KFUL, enter, to KAJO, which is Corona. Now, if I hit the menu button, I can now activate that leg and replace the active flight plan from direct to Long Beach with Fullerton to Corona. And you'll notice the desired track is different. Procedure button, I'll load an instrument approach. We'll do the VOR or GPS. We'll put in baro minimums of, I'm just guessing here, 1200. I think it's higher than that. Okay. And I'll decide to load it, which means it's in my flight plan, but it's not active yet. If I want to activate the procedure, I do that by hitting the procedure button again. Now, if we do it on the MFD, you're going to see some slightly different systems. So the little knob changes pages, the big knob changes chapters. Press and hold the clear button takes you back to the default map 1. So sometimes they do different things. We'll talk very briefly about the Garmin flight control, the built-in autopilot. It is much better than the King autopilots only because King autopilots are awesome and they're very popular and I love the things. But the Garmin flight control system is built in so you don't have to do as much double entry. And we'll talk about that later in autopilots. But if you have it installed, you'll see your dual altitude knob, autopilot on and off, heading mode, which tracks the heading bug, navigation mode, which tracks a VOR, localizer, ADF bearing, or a GPS signal, activating an approach mode. There's your vertical speed button, which again I then use the nose up and nose down off to the right. Your flight level change button, which I don't typically use in piston aircraft. Number 24 is your flight director. 25 is actually hold your current altitude. So if you're climbing at 1,800 feet and you push that button, it will then attempt to hold that by trimming your elevator trim tab. So it's critically important that everybody understand with all autopilots, the GFC or the King autopilots, that every time you change something, go up or go down or level off on an autopilot, you need to assist that with the corresponding throttle movement. If you tell it to climb at 2,000 feet per minute but don't add throttle, it will repeatedly stall the aircraft. If you tell it to go down at 1,000 feet per minute and don't reduce throttle, it will over torque and overspeed your engine. So you really need to help. So every time you push an autopilot vertical button, you need to assist it with the throttle. 26 is your vertical navigation mode. Again, it will automatically, when you get to this waypoint, descend from 4,000 to 3,000, but always help things along with the throttle. And of course, the back course is a critical button if you're shooting a back course instrument approach. Your nose up and your nose down are what we talked about in the vertical speed mode. Now your audio panel buttons are pretty simple. We'll go over them very quickly, but basically if you see the white diamond, that is on. So Comm 1, if you push it off to the left, means you'll transmit and receive on Comm 1. If you just push the Comm 1 button on the right, notice it doesn't say mic, that means you can listen or monitor that radio even if you're transmitting on a second one. Same thing for Comm 2, and same thing for Comm 3 if you're lucky enough to have something with 3 radios. Now the Comm 1-2 split is an option. It's not necessarily built into all systems, but this is very useful in the fact that it lets the pilot and the co-pilot talk and listen on different radio frequencies. And this is really, really helpful if you're doing professional flying or charter type flying, because the person in the right seat can talk to the FBO and say, hey, we're 20 minutes out, please pull the rental car around, while Comm 1 can talk to air traffic control and they don't interfere with each other. So it literally divides 1 and 2 between the left and the right headsets. You absolutely can hook up a telephone system to this. PA is the speakers in the back, and typically that's in a larger aircraft, a Caravan or a jet, where like I used to fly a Caravan, there were speakers in the passenger compartment. I would trigger the PA, and then when I talked, the people in the back could put on your seatbelts, we're about to land, that kind of stuff. Speaker button, which puts the speaker in the pilot compartment on so you can listen to radio transmissions. Of course, the marker beacon and the marker mute button, and you can change it from low to high sensitivity by pushing that high sends button to the right. 13 allows you to listen to a DME system to identify the Morse code. Obviously, Nav1 allows you to listen to the ident, the Morse code system, if you push the ID button. But even without the ID button pushed in, you can still listen to a HIWAS or an AWAS or an ASOS. If you'd like to listen to AM radio, ADF is a great option to have. Same thing for Nav2. Auxiliary is you can actually put your system to connect to an iPod or a different entertainment system and rock out to your own music if you don't want to pay the XM subscription. Manual squelch allows you to actually set the squelch on the intercom to the levels you would like. Playback is kind of an interesting feature, and I think it's pretty commonly misused. So again, I want to stop and tell everybody the playback feature is typically misused. This is something that you probably should not use. Here's the deal. If you miss an air traffic control clearance on the ground, you're writing down an instrument clearance, and you miss the clearance, you can push the playback button, the play button, and it will play back the last radio transmission. So air traffic controller, the clearance delivery guy at Long Beach says, clear to here, here's your route, here's your altitude, here's your frequency, your transponder. And he talks too fast and you miss it. So most people will then hit the play button and listen to it again. The problem is that the controller is waiting for a response from you. So while it's convenient to listen to them again, it's not really the best idea in my opinion, and in my opinion only. People, even worse, actually do it in the air. Air traffic control will say, turn left 060 vectors for the localizer. They don't catch it and they'll hit the play button. Again, air traffic control is waiting for a response from you, and listening to a recording is not the correct action. It really is not. It is much better, in my opinion, to, if you miss part of a radio call, ask them to say it again or say it again slower. Pushing the playback thing is nifty, but when people are waiting for a response, it's pretty common when people push the playback button that air traffic control will interrupt the audio playback. And the good thing is if they talk to you again, it interrupts the playback. You can, though, just keep pushing the playback button 10, 20 times and listen to every radio call along the flight if you want. The only appropriate play button feature for me is on the ground after landing. I'll hit that if the student missed radio calls, so it's a teaching tool. But I don't like it when you're talking to live ATC. I think it's much safer and much better to simply say again. Now, if you hit the pilot ICS button, it turns off them hearing the intercom. So you actually don't want these white lights for the pilot or the co-pilot lit while you're flying, because then you can't talk to each other. It is useful sometimes if you have many passengers. Say your co-pilot wants to talk to 8 people in the back of your nice new shiny Caravan. The pilot can block hearing the intercom and allow the co-pilot to talk. But it's actually part of the pre-flight. It's built into the POH that before takeoff, these are supposed to be turned off. It's actually part of the required pre-flight check. And the little button is the pilot volume and squelch, and the big button is the co-pilot passenger volume and squelch. So if the guy next to you seems really loud in your headset, you can actually turn him down, and you can adjust manual squelch if you have to. And 24 is the button you push when you have any display problems, because it allows both screens to go into reversionary mode. So let's watch a video of using the audio panel buttons and knobs.
You have information.
You'll notice I'm now hearing the ADIS. If I push Comm 2 mic, you'll notice I'm still listening to Comm 1. I can turn on my marker button, make it more sensitive, turn those off. I can listen to nav 1 or nav 2. Eliminate the co-pilot or eliminate the pilot, because basically you're muting the other person, and change the volume and the squelch of the pilot and the co-pilot and the passengers. And reversionary mode then makes both screens show all of the available information. So let's do a quick power on self-test. When you first turn on your system, you'll notice that the MFD goes to a screen showing your plane typically, or in this case a Skyhawk, and says, here's all your database versions. Remember, the navigation database must be current for what? Well, the navigation database has to be current for GPS primary navigation. That means if you're going to rely on GPS as your primary form of navigation, the aviation database, the navigation database, needs to be current. And it must also be current to shoot GPS approaches in the IFR system. If the navigation, which is the aviation database, is expired, you can still file slant gulf. You can still use GPS Enroute as long as you can back it up with other navigation aids like VORs and localizers and NDB and all that good stuff. You'll notice that everything on the left starts out as a red X, and you'll see AHARS line, keep wings level. You really should not ever turn off your system while flying. There's a few rare exceptions, but it takes a second to stabilize. So after everything goes away, you'll now see there's the diamond star. I'll push enter, and that'll bring up the MFD. So let's talk about the primary flight display. This is the left screen, or some people call it the pilot screen. It's the primary flight display because it's directly in front of the pilot. The number 1 you'll see in the top left is your nav frequency, but again, I don't want you to look there. I want you to look on the left side of the MFD as I've shown you. 2 is your airspeed tape. This takes a little getting used to because it moves opposite the way an airspeed needle would move. Your true airspeed is shown below. Your current heading, your turn rate indicator, your standard rate turn indicator is right there. It's a curved bar on top of the HSI. There's your heading bug, and it also tells you the number. If you want to look at the heading box, it will say that's what your heading bug is sent to. Your outside air temperatures down there. These are called soft keys, and they're called soft keys because they actually change. The buttons are below there, and when you push them, the display and the meaning on the soft buttons actually change. So it's not a fixed button like a direct to button. It can actually change. There's your system time, and there's your transponder data box. There's your HSI, which again puts the course or your CDI on top of a DG. Now, HSIs in steam gauge airplanes are typically slaved to a compass. This, of course, is getting direct feedback from a magnetometer. The advantage is that the magnetometer, being solid state, doesn't go wonky in climbs, turns, and descents like a magnetic liquid compass will in a steam gauge airplane. There's where your baro setting is shown. This is your vertical speed indicator. There's obviously 100 feet per minute up, 200 feet per minute up, negative 100, negative 200. That is your reference altitude. Now, if you have the Garmin Flight Control autopilot built in, your autopilot will recognize that. If you have the King autopilot, putting it there is only a memory aid for you. You then have to reset and put the altitude in a second time in the King autopilot. And when you get to that altitude, you'll actually see a blue bug on your altimeter tape. And there is your altimeter tape, which showing we're right at 5,000 feet. There's your comm frequency boxes, your navigation status box. In this case, the LADE active is direct to KORD. It's 51.5 nautical miles away, and the bearing is 105. That little thing right there is the ball in your turn indicator. That's the ball. That's the slip skid indicator, and it never ceases to amaze me how many people, once they get a really nice equipped autopilot plane, forget to use rudder. I promise you, any piston GA airplane that you buy with a G1000 probably does not have a built-in rudder servo, and you absolutely need to use right rudder in climbs. People tend to get out of that habit. That is your attitude indicator, and that gives pitch up at 10, 20 degrees and pitch down 2.5, 5, 7.5, 10 degrees. You can see the individual lines. So here are the PFD soft keys, and let's actually watch a pretty long video and show you what all of those soft keys do and how they change. When I push the inset button, you see things change. That's the inset map to the left. I can turn traffic on and off. I can declutter it, and I'll show you when I range out what the declutter button does. See how it adds and removes information? There's traffic, traffic 1 and traffic 2. Topo is the land data. You can really see it. Now, the more stuff you put on there, the harder it is stuff to see, and that's why I use the Declutter button. Terrain, of course, puts in your TAWS system, your terrain awareness. If you hit back, let's push the primary flight display, and there's all kinds of things you can put on. Synthetic vision, you can turn on pathway, you can turn on or off terrain, your headings, and your airport signs. And that's the horizon heading. Defaults show the default PFD display. Back, PFD, let's put up the wind, and you have option 1, option 2, and option 3, which show 3 different wind displays, and I'll show you those later. That gives you a bearing 2. It looks like Paradise using the GPS. Bearing 2 is also 2, Paradise on GPS. And the reason is you're right now on VOR2. So it depends on what you're using as your primary. You can change it from a 360-degree circle just to an arc. I prefer the 360 degrees. And go back. See that big yellow dot? That's traffic. I can change my altitude units from inches to hectopascals and even meters, which you may have to if you fly internationally. Standard baro, it's 29.92. So anytime you go into the flight levels, you're just going to push the standard baro and remove it. CDI changes your nav source. GPS, VOR1, and VOR2. Most of the time you're flying, it should be on GPS. Here's your transponder buttons, and you can change it from standby to on, which reports your position but not your altitude. Altitude reports your altitude. Ground, which is a standby system. And code. Now you can actually push in the 4 different buttons, but it's kind of hard to do. What I like to do instead is push the code and use my FMS. Big knob moves it, little knob changes it. And then push enter. That to me is quicker and more intuitive because that's the way I'm used to doing transponder. If I push ident, we'll put it into altitude mode. There's the ident feature. You can see the flashing R reply light, and then I put it back in standby. Timer reference brings up timers. Big knob moves the cursor, little knob changes things, enter moves to the next window. So we'll take a 10-minute stopwatch. That'll count down. Then I'll hit reset. Nearest, this is the button you push first in emergencies. Activate the cursor, big knob moves the cursor, then I'm going to push the direct to, enter to, and that will take me direct to the nearest airport that I want to go to. Advisory brings up the alert windows. So you can see how the buttons change, and it just takes a little bit of practice. What I really recommend is that you practice all of this, of course, with an instructor, but with a ground power unit plugged in, so you can just sit there for hours and run your system without running down your battery. Now there are some pretty important annunciations that you're going to see on the primary flight display. If there is traffic near you, you'll get a flashing traffic warning. The V-speed references automatically show you on your airspeed tape what's best glide, what's best rate of climb, best angle of climb, and when to rotate. And again, they're pre-programmed into the G1000, but you can change them if you need to. 3 is your selected heading. 4 is, there's your wind data. And this is one of the different options. This is saying you have a 13 knot headwind and a 27 knot crosswind component. You can actually change it to wind aloft true and just a wind direction angle. There's your inset map, your DME information if you have that installed, your bearing information systems, and the minimum descent altitude or baro minimum that you programmed in that timer reference window, or that you programmed in when you loaded the instrument approach. Here's your flight plan window, which pops up and down by pushing flight plan. Your annunciation window is right there, and we're going to talk about the crew alerting systems and the different levels and types of warnings that you'll get there. Your selected course is shown by an arrow as well as a number that says CRS. There's your current vertical speed, and on this display we're 350 feet going down. There's your glide slope indicator. That's green. If it was a glide path indicator, it would be pink. Your marker beacons happen right there. That's what it'll look like if you're going over an outer marker. Now you're passing over a middle marker. And now you're passing over an inner marker. If you have an integrated automated flight control system, in other words, the GFC 700 autopilot, and you have any warnings or problems with that, first of all, let's show you the terrain warnings. Hey, you're getting too close to terrain. And there's the autopilot warning. So, how do you get better at all this stuff? Well, I'd like to offer you a couple steps. One is free. And I really recommend this. Read the Pilot's Operating Handbook, or it's typically called the Garmin Pilot's Guide. True story, and it's happened over and over and over. People have hired me to come to them. They've had a Garmin equipped plane for a couple years. They don't really understand it, and they just want me to come out for 2 or 3 days, pretty fast, pretty affordable, just to make them better. And I'll say, all right, well, let's look at the Garmin's Pilot Guide. And they're very proud that it's still in the original shrink-wrapped plastic. You really do need to take this out and go through it page by page with a highlighter, and even better is page by page while your airplane is hooked up to a ground power unit, and you can practice pushing all of these buttons. Another great resource that's also free is walk yourself all over to the computer, go over to pilotsafety.org, click on Ask the Experts, and if you have 1 or 2 simple, easy to answer questions, I will be happy to email back. One thing that's really important for all y'all to know, I volunteer for pilotsafety.org. I have a family. I have a real job. I'm happy to answer 1 or 2 simple questions. There have been people in the past that have gotten very upset that I told them I could no longer answer questions on the 4th or 5th question. I'm not a free flight instructor. I've also had people get upset when I didn't reply to their email at midnight. I'm a volunteer. I'm happy to help. I'm certainly happy to answer 1 or 2 basic questions. Just give me a day or 2, and I'd be happy to help you out anytime I can. And of course, you can actually hire me to come to you and do one-on-one training. I hope you all have learned. This is not the most exciting chapter in the DVD or your online program, but I really think it is the most important and something you should watch on a fairly regular basis, because people with a really good understanding of the systems do very well in an emergency. So it is critical to have this kind of background information in there. We'll see you on the next video or the next chapter. Thanks again.